Hello everyone, I'm Chemist Mary, and in the course of this video I'm going to be solving this easy question. But I want you to watch this video to the end because I know that this video will pass even 5 minutes, but I will urge you to watch it till the end because you will learn a whole lot. So let's go on. Now it says the number of molecules of carbon 4 oxide produced when 10 grams of calcium triisocarbonate 4, also known as limestone, is treated with 0.2 dm cube of 1 molarity HCl in the equation. Okay, now we're given the equation. Now questions like this, it is assumed that it is already balanced. That was why it was given. But in order to be on the safe side, I always ensure what I check if it's balanced. Now let's check together. We have one calcium. On the reactant side, we have one carbon. Product side, same thing, one carbon. We have 3 oxygen. Here we have 2 oxygen here, plus this one oxygen, which is 3. These 2 indicates that everything here, there are 2. 2 hydrogen, 2 chlorine. 2 hydrogen, as you can see, 2 chlorine. Now this equation is balanced. Now back to the question. The number of molecules of carbon 4 oxide. Now when you hear number of molecules, or in a question whereby given number of molecules, whereby we are told to find number of molecules, or to find number of atoms, or to find number of ions, or number of electrons, any of them, this formula comes to mind. Na is equals to what? Nl, where Na is the number of elementary particles. The number of elementary particles, like I said earlier, it could be number of atoms, it could be number of protons, number of electrons, but in this case we are told to find number of molecules. So this is the elementary particle we are asked to look for. We don't know. Okay, now n, this small letter n represent number of moles. Number of moles of what? Number of moles of this carbon 4 oxide. Okay, we were not given in the question. And L, Avogadro's constant. Avogadro constant, as we all know, is 6.02 times 10 raised to the power 23. And if you don't know before, you know now. This is Avogadro's constant. Now, we cannot be able to use this formula because we are not given in the question number of moles, but we're given what clues in order to find the number of moles of carbon 4 oxide. So when we find the number of moles, we will apply this formula, which says Na is equals to Nl. Okay, now in order to find the number of moles of carbon 4 oxide, we have to get back to what? The parameters in the question. Now let's look at the parameters. Now what did they say? It says the number of molecules of carbon 4 oxide produced when 10 grams of limestone. Okay, now we can rightly say, let's just move to this side of the book. Sorry. Now we can rightly say mass of limestone. Mass of limestone is what? 10 grams. Yes. Okay, let's go back again. Is treated with 0.2 dm cube of 1 molarity HCl. So you agree with me that volume of what? Of HCl, according to the question, is 0.2 dm cube. And also our what? Molarity, also known as concentration, according to the question, is 1. Now with this we can find the number of moles of hydrogen chloride, which will give us N is equals to Cv. Number of moles of hydrogen chloride, N equals to Cv, which is concentration times volume. Now take note, assuming this dm cube was in cm cube, it would have been divided by 1000, but since it's in dm cube, we are going to solve straight up. So the concentration was what? 1, and the volume is 0.2. Now 1 times 0.2 will give us 0.2 moles. So number of moles of hydrochloric acid is 0.2 moles. Now we're also given mass of limestone 10 grams, and we can use this formula to find the number of moles of limestone, which is mass over molar mass. Now we're given the mass to be 10 grams. Now molar mass, let's calculate it together. Molar mass of CaCO3, which is the addition of what? Of their atomic numbers, of their mass numbers, sorry. Mass number of calcium is 40 plus 12 plus 16 times 3, which is 48. When you add up everything, we have 100 grams per mole. Now this will give us 100 grams per mole. Grams strike out grams. Now when you have something like this, 2 zeros here, you move it twice, 1 2, which will give us 0.1 mole. Now you can see in the question we have the mole of limestone and the mole of hydrogen chloride. Now let's bring out our equation. You can see it here. Limestone reacting with excess hydrochloric acid to give calcium chloride plus water plus carbon dioxide. Let's bring out the equation. Okay, limestone reacting with excess hydrochloric acid to give us what? Calcium chloride plus water plus carbon dioxide. Now, what are we looking for? What is the reason for this relationship? The reason for this relationship is to find the number of moles of what? Of carbon dioxide. Now, which are we going to use to form the relationship? We don't know the one we are going to use to form the relationship because we have number of moles of limestone. You can see we have number of moles of limestone, 0.1 mole. We have number of moles of hydrochloric acid, 0.2 moles. So which are we going to use to form relationship to find what? The number of moles of carbon dioxide in order to be able to use this formula. That is when limiting reagent comes in. Now this is the secret behind this question. Limiting reagent. You don't just choose the one to use. Instead, you use the limiting reagent. Now what is a limiting reagent? A limiting reagent is what? A limiting reagent is a reactant that is what first of all used up in the reaction, and it determines the product to be what? To be formed. It limits the product that is being formed. Now I said the limiting reagent is the one that is first used up in the reaction. Now you agree with me that this is 1 mole, this is 2 moles. Why? Because the numbers in front represent the number of moles. Since there is nothing here, it means it's 1, and we have to. And from what we solved, you can see that mole of limestone is 0.1 mole, and mole of what? Hydrochloric acid is 0.2 mole. So the stiochiometry is even in the right ratio, 1:2, 0.1, 0.2. Now you agree with me that between this reactant, limestone and hydrochloric acid, you agree with me that limestone will first of all get used up before hydrochloric acid. This therefore makes limestone the reducing agent. Now what do I mean? Let me explain this reducing agent further. Now imagine I have 5 flour. I have 5 flour and I have 10 butter. Okay, I have 5 flour and I have 10 butter, and I need to make cake. Now this will determine the number of cake to make, right? Okay, now I have 5 flour and 10 butter, and I need 1 flour plus 1 butter to give me 1 cake. Please follow me. Now if I take 1 flour, 1 butter, it will remain 4, it will remain 9. I continue taking till I get 5 flour and 5 butter to give me 5 cake. Now you agree with me that after 5 flour, I will no longer have any flour remaining, but I will still have 5 butter. But I cannot make use of the butter because flour has already been exhausted. So therefore, flour becomes the limiting agent, and it limits the product formed, which is only 5 cake. So this 5 butter is of no use because only 5 cake can be formed. Now coming back to this question, I have limestone, I have hydrochloric acid. 0.1 mole will give me 0.2 mole. Now this 0.1 mole will get exhausted first before I even get a chance to use 0.2 mole. So therefore, this 0.1 mole of limestone becomes the limiting agent. Why? Because it is the reactant that gets used up first, and it will determine what? It will limit the product to be formed. So therefore, I'm going to use limestone to do what? To form my relationship. So therefore, I'm bringing forth limestone and what? And carbon dioxide to find the number of moles. So from the equation, you will agree with me that 1 mole will yield 1 mole of this. So therefore, from what we solved earlier, 0.1 mole will yield what? I don't know, x mole. But since they have the same value and you do your cross multiplication, the number of moles of carbon dioxide will become what? 0.1 mole. Now we can come back to our formula. Now we have number of elementary particles with number of molecules. We now give us what? Number of moles now is 0.1 times Avogadro's constant 6.02 times 10 raised to the power of 23. Now applying indices to this question, if I move these ones, it will give me 1 times 10 raised to the power of minus 1 times 6.02 times 10 raised to the power of 23. Okay, Now let's move to this side a little. Now indices, bringing numbers to one side. 6.02 times 1 will give me 6.02 times 10. Indices that have the same whole numbers, so bringing down the indical values, I have -1 plus 23. Now my number of elementary particle, which is the number of what molecules, will therefore be 6.02 times 10 raised to the power of 22. Now this is our final answer. Now if you find this video helpful, please click on the plus sign to follow me, like, share and comment. And if you go to my bio, you see the link that will take you straight up to my YouTube channel, where you can subscribe and click on the notification bell so that you will receive more and be informed when my videos are released. Thanks for watching. God bless.